In this lesson, we are going to create a thread on the nose of this part. Threading is a process that lets you use a single point tool to create threads on an inside diameter or outside diameter. You can create single lead or multiple lead threads of any pitch. On the Inspect toolbar group, select the measure icon. Select the front nose of the part. Since I am in inches, I get a diameter of 0.787, but that's not a standard inch size. In the Measure dialog, click the pull down and under Secondary Units, select mm. Now it displays the metric values next to the inch values. You can see this is actually a 20 mm nose piece. A common thread for a 20 mm diameter is a 1.5 mm pitch. So that's what we're going to be doing for this example. On the Turning Toolpath group pull-down, select the Turning Thread icon. On the Tool tab, press Select to enter the tool library. Inside the Fusion 360 library, select the Turning Sample Tools library, and then, from the list in the middle window, at the bottom of the list, click the tool that says OD Threading Tool. Press Select. Let's go to the Geometry tab. For the thread faces, select the 20 mm front nose. The confinement area controls the start of the cut and the end of the cut on the selected face. The front side stock offset is in relationship to the front of the selected face. I like to have about 2 thread leads for a lead-in. Let's type in 3 mm because we can easily enter inch or metric numbers. The backside stock offset is in relation to the back of the selected face. I don't want to go past the back face. We will leave that set at 0. Let's go to the Passes tab. As a default, the clearance is set to the maximum distance for safety. But if you want to start and end closer to the front nose, select the Selection option from the pull-down and pick the same spindle nose. Now you can adjust the offset in relation to this diameter. I'm going to leave it set to 400 thousandths. Let's go to the Passes tab. We are doing a right-handed thread, so there's nothing to change for the threading hand parameter. Let's look at the tooltip for the thread depth. Thread depth is based on the difference between the major and minor diameters divided by 2. Let's look at this chart for a 20 mm by 1.5 mm thread. I'm going to take the 2 extremes from the major diameter of 19.97 millimeters and the minor diameter of 17.93 millimeters and round them to 20 millimeters and 18 millimeters. 20 minus 18 equals 2. Divided by 2 equals 1 millimeter. So let's set the thread depth to 1 millimeter. Nothing to convert, just use the metric value. Next, we need a thread pitch of 1.5 millimeters. So just enter 1.5 mm for that parameter. Next, let's look at the tooltip for the in-feed mode. This determines if the tool will plunge in straight or feed in at an angle, reducing the load on the insert. It's common to set this to a reduced in-feed and set the in-feed angle to an angle of half the insert angle less a half of 1 degree. This reduces the insert load and does a cleanup of the in-feed. So we are going to use these same settings: reduced in-feed and in-feed angle of 29.5 degrees. Other threading options that we are not going to change, but are useful to know: do multiple lead threads is used to create multiple lead threads without creating multiple threading operations. Fade thread end pulls the thread off of the part at the end of the cut. Spring pass takes a single additional pass after reaching the final depth. Use cycle will output the threading as a machine can cycle. This creates more compact code, but watch what happens when I enable it. I lose the fade thread end option. The reason is that can cycles can't do a fade thread end. So if you want a can cycle, you may lose capability. This will happen anywhere in Fusion where the Use Can Cycle option is available. Can cycles just can't do as much as native Fusion toolpaths. We are going to leave the defaults on the Linking tab and just press OK to generate the toolpath. And there is our toolpath for the thread. Let's see the simulated toolpath. Right-click on the setup, select Simulate, enable stock, and press Go to the end of the toolpath on the player controls. Next, turn off the model visibility in the browser tree. Now we can see the threads in detail. Don't forget to turn the model visibility back on when you are finished looking at the simulation. In this lesson, we learned about the Turning Thread Toolpath strategy, selecting a tool from the library, containing the cutting area, figuring out the threading depth, entering metric values for an inch project, the advantages of not using can cycles, toolpath simulation, and model visibility. Press Ctrl+S to save the part, Command+S on the Mac.